Welcome back to Learn ADS tutorial series. In this video, we will learn that how we can create a phase array antenna in Keysight Advanced Design System. Create a new layout. Then click on Layer Stack Up. And create a new layer stack up. Click on Substrate to set the thickness. Select the substrate from the options. I am going to use the Rogers 4350. For other substrates, click on three dots and click on Add Substrate from the database. Choose your desired substrates. Now, come back and now click on Conductor and change the type from Perfect Conductor to Copper and set the thickness to 35 micrometer. Save the setting. Now create the element of antenna. It's your choice that which type of cell you want to create. On the right side in the Properties tab you can modify the dimensions. Use the copy-paste command. From the menu bar, use the union command to merge the items. From the menu bar, select the vertex to arc command and enter the radius of arc. I am using 200 micrometer as an arc radius. Select all the vertex to convert it to arc. Use the copy-paste relative command and make the array. I am creating 4x4 array. Now, in the next step, connect the port to the elements. This is very important step, because the position of port has the significant effect on the results. This is the point where you will connect the coaxial cable using SMA connector. All the cells are connected to the ports. In this way we have 16 ports. Now our phased array antenna is ready. Now to simulate this antenna, create an EM setup. All the settings are okay. The only thing we need to change is the frequency plan. Let's simulate this antenna from 10 GHz to 80 GHz. In options, also enable the edge mesh to get accurate results. In output plan, save currents for all generated frequencies. Now save the setting. Now run the electromagnetic simulation. It will take 5 to 10 minutes or more depending on the type of geometry, substrates, complexity, etc. When the simulations get completed, the results will appear on the screen. Results are looking good. We have a good response at around 76 GHz. This plot is very useful, and you can check all the S parameters by selecting from the bottom slide bar. For example, if I want to see S33, then slide the bottom bar to check the response. There is a good return loss at around 76 GHz. Let's check the current pattern at different frequency and ports. In the bottom bar, select Plot Properties. Check the Animate button. In the scaling options, you choose the dB scale to see the extreme values. See how the current flows from one element are coupled at the other ports. Click on the In the Solution Setup tab. In this option all the simulation frequencies are listed, and on the top side all the 16 ports are listed. You can see the current animation at any port and frequency. Check the current animation at port 9. In this way you can see the current animation at any port. These visualizations are extremely helpful in understanding the coupling effects and overall performance of your array. You can also enable the arrows. These arrows shows the direction of current. These arrays are too big as compared to the antenna. You can change the size of arrows for clear view. Check the response at some other frequencies. You can choose any port from the available ports. You can also change the view from these options. Now change the frequency plan. Let's simulate it from the 60 GHz to 100 GHz. Click on the Run button. Wait for the simulation to complete. These are the results. Wow, results are amazing. I was not expecting such results, because I make this antenna randomly. We get a good peak at around 87 GHz. This is all from this video. Thanks for watching. Please don't forget to like, share my channels.